calculate the total variable cost. The total variable cost of the 6,400 units of the new product. What are we given? You need the total variable costs. Okay? You need the total variable costs of the 6,400 units of the new product. Whenever it's something new, always think about running a curve, because running a curve applies in a scenario where you are dealing with a new item, okay? Because in that process, there is room for improvement, and there you can apply the learning curve or the learning index. So what are we given? The company has developed a new product which it will launch next month. The company has developed a new product which it will launch next month. During the initial production phase, the company expects to produce 6,400 units in batches of 100 units. Also, this is something that you need to know. In batches of 100 units, it means that one batch contains 100 units. One batch comprises of 100 units. Okay, the first batch, now you will see the language. The first batch, the focus is on the batch, not on the unit. Understand the language of the examiner. Otherwise, you can end up making mistakes. Here they are saying the first batch, not the first unit. The first batch to be produced is expected to require 25 hours of direct labor. So you have the time. The time expected to produce the first batch is 25 hours. The following details are expected to apply throughout the initial production phase. You have direct material cost per unit. This is per unit. Okay. You have direct labor shillings 10,000 per hour. This is per hour. You have other variable costs per unit. Then a 90% learning curve is expected to apply. You have the learning index for a 90% learning curve is this one. Examiner has helped you here. Remember, the learning index is B. B is the learning index, which is equal to log R over log 2. Log R over log 2. Okay, so how can we answer this one? Is it very easy? I believe by now at least you should be seeing something a bit easier. Okay, so this is June 2013. This is June 2013. And we are dealing with what question? Is it question 4 or question 3? Question 4. Part A. We need the variable costs. We need the variable costs. Now, colleagues, every time you find that you're dealing with learning learning curve. Okay. The learning curve only affects your labor cost. It only affects your labor cost. Other things remain the same, but it only affects your labor cost, especially on the time. Because here you have direct labor, but which time are you going to use? Because they said 10,000 per hour. So which time are you going to use? That time you use must be coming from the workings where you use the concept of running curve. Okay, so other things are easy. So what we are going to do, okay, so here you have you need total direct variable cost. You can have the first variable cost in that question is direct what? Direct materials. What is direct material cost? It's shillings how much? They told us it's what? Shillings how much per it's shillings. Okay. The direct material per unit is shillings 4,000. But how many units? You have 6,400. Those are the units. 6,400. Here you have each unit is 4,000. Then we multiply by the number of the total units. How much do you get?
25.6.
You get 25.6 million. Okay. Then direct labor cost. Direct labor cost. They told us that it is shillings what? 10,000 per hour. But do you have the time? No, you don't have the time. We are going to look for that. Then other variable costs. They told us it is what? Other variable costs, it's how much shillings? Other variable costs, it's shillings 2,000 per unit. So I have the total units. So I get 2,000 times 6,400 units. Here you get how much?
12.8 million.
Okay. I think those are the only things you have. You'll be in a position to get total variable costs. So you need to do a working here. I can put here working one to get that time. To get that time, I can put here working one. So how do you get the time? How do you get the time? From y is equal to, or I can simply say, okay, from y is equal to ax power what? Ax power b plus 1. Okay. Oh, no. Only this. I can get my total time. Remember, when you use this approach, I keep on saying this. When you use this approach, the answer you get will be per unit. But I just want the total time. The total time spent. The total time spent for how many for 6,000, but now, colleagues, let me also see it. As you get that time, always look at A. Always look at A. A is in terms of what? Is based on units or it's based on batches? The first batch to be produced is expected to require 25 hours. So here you're dealing with batch, okay? You're dealing with batch. You're not dealing with units. So I can say the total time for 6,400 units, or another person can say the total time for how many batches? For how many batches? Remember one batch contains how many units? One batch
100.
contains 100, 100, 1,000. One batch contains 100 units. All right, yeah. 100 units. 100 units. 100 units. Now I want to convert the 6,000. The 6,000. Okay, I need a batch. The number of batch here. The number of batches in 6,400. In 6,400 units. Or another person can say 100 units is equal to one batch. 100 units is equal to one batch. What about 6,400 units? All the same arrangement. This arrangement is the same. You just choose what you want, which is easy for you. But 100 units is equal to one batch, because I said one batch in batches of 100 units. So it means that one batch is equal to 100 units, or 100 units is equal to one batch. So if I want to know the number of batches here, I get 6,000. I get 6,400. I multiply by 1, then the answer you get, I divide by, here I'm cross multiplying. I divide by 100 units. So here you will get what? Those are how many batches? Those are 64. 64 batches. So it means that I will say the total time, instead of saying the total time spent for 6,400 units, I will say that the total time spent for 64 batches, will be equal to, I get my A, I multiply by X, that is the cumulative number of units. Then I say power B plus 1. When I add this one, it means that I'm getting the total time, not per unit. Okay? So what is your A? What is your A? They gave you A will always be given in the question. The time it takes to produce one batch. The time it takes, they told us how many days? Are we given days or time or hours? The first batch to be produced is expected to require 25 hours of direct labor. So it means that here your A is 25. Your A is 25. Then times your X. Your X is the total number of batches, 64. X is cumulative number of units. Here we are dealing with batches, not units. So it will be the cumulative number of batches, which are 64. Then power b plus 1. Okay, power b plus 1. But now, in a scenario where you're not given, in this question they gave us b direct. But you will find that there are scenarios where you're not given b. So b is always equal to log r over log r. Log r over log 2, which is equal to log r in this question is 0.9 divided by log 2, which is log 0.9 divided by log 2. You must get that it's given in the question. That is the one that is given in the question. But there are scenarios where that one will not be given to you. Okay, so I need b plus 1. So b plus 1 is negative 0.1520, then plus 1, which is equal to what? Negative 0.15 plus 1. That is 0.848. All right. So I substitute here. I substitute to get my total time. So total time will be equal to, where there is b plus 1, I simply put power 0.848. And what do you get on the calculator? It will be 25 times 64 power 0.848, which is 850, point 317 hours. So that's what I have. This is the total time you need to produce what? To produce 64 batches, or to produce 6,400 units. Remember, 6,400 units is equal to 64 batches. So I substitute. I go back to my template. I now substitute. So the time you have here is 850.317. These are hours. So what do you get? What do you get? This will be shillings, once or 10,000. That is 10,000 times 850.317. So I get okay, well, 8.5 million. If you want to keep your figures in millions. All right. So finally, your total variable cost will be add, and tell me the answer. So you add and tell me the answer. How much do you have?
46.9 million.
46?
46.9.
0.9 million. So that was the answer for part A. You see, that is the answer for part A. Very easy, but you can fail. You can fail when you don't know how to use the learning curve formula. Okay, so that is part A. That is part A. What about part B of this question? What about part B? What about part B of this question? What are they telling us? They are telling us you have 6 marks. You need the rate of learning. What is the rate? Calculate the rate of learning of direct labor at which the initial production phase profit target would be achieved, assuming no other cost savings can be made. What are you given? Here it means that on required part, you're looking for R, the rate of learning. That is R. So you have shown your computations to the finance director, who has now told you that the company needs to achieve a total variable cost target of shillings 45 million for the first 6,400 in order to achieve its initial production phase profit target. Remember in our first part, what was our variable cost? The total variable cost? Part A, it was 46.9 million. Now the target is to have a total variable cost of shillings 45. How can you achieve that target? Obviously, the labor cost must reduce. The labor cost must reduce. So it means that for you to reduce that labor cost, the rate of running must change. The rate of running must change. So you need to get that. Okay. If the rate of running was 90%, for you to achieve your target, it should reduce to a certain percentage, because if the rate reduces, then it means that you will save on the labor costs. So how can we get that rate that can help us to achieve this target? You as finance manager, you should be knowing these things. You as cost accountant, you should be knowing these things. You as an accountant, you should be knowing these things, especially if you're paying your workers based on time. If you're paying your workers based on time, this concept is very, very key. Train your workers. Just that the issue is always on getting that R. Okay, now how can you get R as an accountant, as a management accountant? Okay. Of course, as I said, the rate can only change. The rate can only change. Sorry, the costs can only change if there is a change in what? In labor costs. In short B, part B, you need to achieve a total variable cost of 45 million. That is from your direct materials. These ones will not change. And then direct materials, let me just copy what I have here. Let me just copy this. Let me just copy this a minute. Save for some minutes. Now this one, will change. This one, We are going to do a working. Other things will remain the same. Then here, you need a target of 45 million. 45 million. That's what you need. But for you to get this direct labor cost must change. This direct labor cost must change. So it must change to what? Initially you had what? Initially you had 8.5. Initially you had 8.5. But it will change. For you to achieve a target of 45 million, you need a direct labor cost of how much? You need a direct labor cost of how much? Naomi,
6.6 million.
6 point, that's what you need, 6.6 million. That's what you need. That's what you need. Okay, that's what you need. Or you can look at this. It's the initial. Of course, once you know that, it means that here it will be initial. Initial, what was your initial labor costs? Your initial labor costs. Your initial labor costs were shillings 8.5 million. Okay. But the target labor cost, the one you want to achieve, is shillings 6.6 million. Okay. Now, what does that one mean? You have a reduction. You have a reduction in labor costs. You need a reduction in labor cost of shillings. The difference is what? 1.9 million. That's what you need to reduce. Okay. But this one doesn't, really this one will not apply it anywhere. Just I'm trying to show you that you need a reduction in labor costs of this. This is the one that is very, very key. This one, very, very key. Okay, so now what are you going to do? Because you need R, How can you get R? How can you get R? How can you get R? How can we get R? They told us other things are not going to change. That's why we maintained. No other cost saving can be made. That's why we maintained material costs, other variable costs the same. Okay, so how can we get R? Remember, initially, when you look at our question, the direct labor was shillings 10,000 per hour. 10,000 per hour. So if it's 10,000 per hour, one hour of labor, 1 hour of labor. 1 hour of labor costs shillings 10,000. So you need to know how many hours. How many hours for you to, how many hours you will use as labor hours in CAS 6.6 million. Because that's what you have here, 6.6. So you need how many hours to incur that? So your x will be 6. No, when I use x, most people get off. That's why sometimes I tend to avoid the x. But we need the total hours. We need the total hours. We need the total hours in this amount of money. So you will get 6.6 million. We are looking for x divided by, it's like cross multiplying. You get this 6.6, you multiply by 1. Here you multiply by 1. You're cross multiplying. Then over x times 10, which is 10,000 x. So I will just divide here by 10. By 10. I will be in a position to know the hours. So on your calculator, put all zeros. Put all zeros. That is 6,600,000 divided by 10,000. I have 660 hours. That's what you have?
Yes.
That's what you have. So I have this time. Who can tell me from our formula of running curve? Who can tell me this one is what? Is it y? Is it a? Is it x? Is it b? It's what? From our formula. Okay. 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 I want to hear from you. Okay. We don't have this. We don't have this in our formula. Remember, you need to understand this formula very well. You need to understand this formula very, very. Machine can disturb me. Wow. You need to understand this formula very well. Y is cumulative average time per unit. The total time, but per unit. Not this is the overall. This is the time you need, the overall time you need for all 64 batches. This is the time you need for all. This is for all 64 batches. But this y is the cumulative time per unit. So here it will be cumulative time per batch, because here we are using batches per batch. So here, how do you get y? It will be this over this time, the whole of this, then divided by a number of batches, because this y is per batch, per unit. Okay, so here you get what? You get 10.31 hours. That is per batch. That is per batch. Then A, already we have A in our question. They told us you need 25 hours. You need 25. This is the time to produce the first unit. Here we are using the first batch. That's what they told us in the question. The time to produce the first batch, that is 25 hours. In the question. Okay. So here, what will be your x? Your x. Okay. By coincidence, it is x. Okay. Your x is what? You're looking at how many. This is the cumulative number of units. But here we are talking about batches. X is cumulative number of batches, and we have how many? 64. What is our B? What is our B? Our B is log R. Log R. Just allow me to just copy from this side. So our B is this. So we are looking for R. We are looking for R. So what does that one mean? I have almost everything, but I don't have B. But I can get B. Colleagues, be creative in an exam. Be creative. So I substitute. Remember, you're looking for R in this question. So where there is Y, you are going to put what? We have our Y as 10.31 is equal to, I have my A as 25, then times X is 64, power B. I don't have that B. I don't have that B. I can first continue and I get B. Once I get B, I will be in a position to get R. Are you seeing that? Once I get B, I will be in a position to get R. So let me first work out and I get B. How do I get B? It will be 64 power B. Power B is equal to, I want to remain with 64 this side, so it will be is equal to 10.31 divided by 25. So 64 power B will be equal to what? What do you get here? That is 0.4124. Now once you reach, how can you get B? How can you get B? You take square root of B. Colleagues, how can you get B? How can we get this B? Which idea can we use here? Which concept can we use here? Introduce log base 10. Log base 10 both sides. Both sides. Now, when to those who dodge the math, introduce log to base 10 both sides. So it will be log. It will be log. I can simply say log 64 because already that log will be in base 10 power B. Here it's, I don't need to put here in an exam. In an exam, don't struggle putting here base 10. Already by telling the examiner, don't struggle doing this in an exam. Even if you do this already on your calculator, that calculator is in log base 10. Okay, so it will be log. I am saying introduce log 10 both sides. So I put it this side and the other side. So this one will be log 0.4124. Now, do you see this B? Do you see this B? You will say simply here, your B, avoid wasting time. Your B will be simply log, will be simply log 0.4124 divided by log 64. On your calculator, what do you get? It's like this, when you have this log comes this side where it becomes like B log 64 is equal to log 0.41. When you have that thing, but I just wanted to simplify. So you want to remain with B alone. So you divide. What do you get on your calculator?
Negative 0.213.
Negative 0.213. That is your B. So you have B, but recall that B is equal to what? B is equal to this one. You need R. You need R. So you have B. So it means that this one will be equal to negative 0.2113. How can you get this R? How can you get this R? So it means that I will be left with log, I cross multiply, I will be left with log R is equal to negative 0.213, then times log 2, times log 2. Okay, log R will be equal to what? Okay, tell me on your calculator, log R will be equal to what? Get negative that times log 2, what do you get?
Negative 0.708.
0. You have 7? How?
708.
But I have a different one. How? Negative 0.213 times log.
Sorry, I divided instead of multiplying.
Remember, we are cross multiplying. This is over 1. So you take this side, this one, this side. You multiply. What do you get?
Negative 0.0641.
641. Colleagues, in an exam, pay attention to details. So finally, how do you get R alone? How do you get R? How do you get R alone? So to remove this log at this side, you will now get anti-log of this anti-log of negative 0.0641. Do you know how to get anti-log on your calculator? Do you know how to get anti-log? Anti-log of that. Do you know how to get it on your calculator?
It is shift then log.
It is shift then log. Then write that figure. Shift log. Shift log, then write that figure. 0.0641. You get what?
862.
0.863.
863.
86 only.
8627.
2728. Okay, I think I have 0.86277. So finally, what is your R in percentage? Your R in percentage? That is rather 86.280%. And that's what examiner needed. Is it clear? You need to be very, very careful and follow these steps very well. Follow these steps very well. Okay. So that's all for that question. We'll get time and go through it. But these are good questions for section B. These are good questions for section B.